Hello, one and all. Thank you for joining me. Root Beer here, looking at question 22 on our grade 7 Gauss paper. In the 6-digit number 1A, B, C, D, E, each letter represents a digit. So we're not multiplying these together. It's a number in the hundred thousands. Okay. We could even read it out. 100, A, T, B, 1000, C, 100, D, T, E. It kind of sounds weird when I do that. But, you know, we could read it out. The point is, it's meant to be read as though they were digits. Alright, given that 1 ABCDE times 3 is ABCDE1, basically we just sort of cycle the 1 to the 1's digit, the value of A plus B plus C plus D is. Okay. So, well, what have we got? Some number, some 6-digit number, and when I multiply it by 3, it ends in a 1, and it goes E, D, C, B, A. Okay, well, how do we multiply regularly? You multiply units digit first, and then tens digit, and so on. So what should E be if I multiply it by 3 and get a 1? And since we're going to be multiplying by 3 a lot, it might be worthwhile to write out your 3's times tables when it comes to digits. You don't have to, but I feel like this might help. I guess we could add in 0, but that's not going to be very interesting. So 3 times 1 is 3, 6, 9, 12, 15. Right now we're looking for anything that ends in a 1 like that. 7 times 3 ends in a 1. In fact, it's going to be the only one. Alright. So this sort of tells me that E needs to be 1. Or, sorry, not E needs to be 1. E needs to be 7 because it ends in a 1. And once I realize that, well, we can start filling in. Suddenly we have 7 and a 7 here. So 3 times 7 is 21. We carry the 2. And now we'll have 3D plus 2 ends in a 7. Well, if 3D plus 2 ends in a 7, subtract 2 from both sides, 3D needs to end in a 5. So which one of these ends in a 5? Well, the 5. So that, and it's the only one that ends in a 5, so we get to replace D with 5. So 3 times 5 is 15, plus 2 is 17, and we carry a 1. 3 times C plus 1 ends in a 5. So 3 times C must end in a 4, and that's going to be 8. And we just keep going on like this. The nice thing about 3 is there's never going to be any ambiguity. Each of the numbers only appears once as a units digit. 3 just sort of scrambles them around. Okay, so 3 times 8, 24, plus 1, 25, so we'll carry a 2. So 3 times B, 3 times B plus 2 ends in an 8. So 3B ends in a 6. Let's make this B a little more clear. So 3B ends in a 6. What number possibly ends in a 6? 2. So B is going to be 2. And we have 3 times 2 is 6, plus 2 is 8. Carry nothing. So 3A needs to end in a 2. Well, that sort of singles out A is 4. And we just need to double check, does this work out in the end? So 4. 4 times 3, 2. Carry the 1. 3 times 1 plus 1 is indeed 4. So there we go. And what were we asked? We were asked for A plus B plus C plus D plus E. So 4 plus 2 is 6, plus 8 is 14, plus 5 is 19, plus 7 is 26. So 26 is the sum of these digits. And so 26, where are you? B. So we'll bubble in B, and then we'll move to question 23, the midway point of our Part C questions. I will see you there.